Unit 10, Objective number 3, Multiplying Polynomials. First, we'll take a visual approach to multiplying polynomials. We can see how multiplying polynomials works by looking at the area of blocks. So for example, if we have a block here with a side length of x and a side length of x, we know the area of a rectangle or a square is side length times side length, or length times width. So the area here would be x times x, which we can write as x squared. Now, imagine we have two of those blocks, both with a side length of x. And here we have a side length of x. Now, if this side length here is 2 and 2, and remember, all of these are x, so this whole thing is a rectangle, then our width here is still x, but our length is the sum of all of these parts. So we have 1x, 2x, plus 2, plus 2. Well, that's all 4. So now we have this area. We have, or this length. We have 2x plus 4, and here we have x. So if we multiply those together, x times 2x plus 4, we'll get the area of our rectangle. Well, if we look at the area of this block, it's x times x is x squared. This one is x times x. This is still an x height here, or width. So x times x is x squared. Here we have 2 times x, and here we have 2 times x. So when we multiply this out, we're going to get an answer of 2x squared plus 4x. If we were to just add up the sum of the areas of the individual parts, we'd have x squared plus x squared plus 2x plus 2x. Well, x squared plus x squared is 2x squared. 2x plus x is 4x. So we get the same answer. So we can see how multiplying polynomials works, because what we're doing is we're finding the area of these spaces that have these as their dimensions. Multiplying polynomials is based on the distributive property. Remember, the distributive property is a times b plus c inside parentheses equals a times b plus a times c. That is, we take this term on the outside, multiply it by each of the terms on the inside, or we distribute our outside term through to each of the terms inside the parentheses. So if we are looking at this example here, we're going to distribute that 3 through our parentheses. So we get 3 times 2x plus, and I use plus here because I have plus here. So I have 3 times 2x plus 3 times 4. And then I'll simplify this. 3 times 2x is 6x. 3 times 4 is 12. So there's my answer, 6x plus 12. Multiplying polynomials is based on the distributive property, and even when we aren't distributing a single number on the outside here, all of our polynomial multiplication processes will come back to this property. Now, multiplying monomials involves multiplying the coefficients together and multiplying the variable parts together, and then writing our answer as a monomial. Remember from Module 10.1, a monomial is a polynomial that doesn't have any doesn't have any addition or subtraction in it. So the first thing we're going to do here is multiply our coefficients together. My coefficient here is 3, and my coefficient here is 2. So I have 2 times 3. Times, then I have an x and an x squared. Then I have a y and a y. So all I've done is regroup these so that my like terms, or my common numbers here, are next to each other. Now, 3 times 2 is 6. X, without an exponent, has an invisible exponent of 1. When we multiply two numbers that have the same base, we add their exponents. So 1 plus 2 is 3. So I have 6x to the third. Again, with my variables, my invisible coefficients are 1 and 1. So y times y is y squared, or 1 plus 1 is 2. And that's my answer. That's my monomial. You'll see it's a monomial because I don't have any addition or subtraction. These terms are all multiplied together. If I had more terms, I would follow the same steps. I combine the terms that I can. So I should have each one of each base here. So a number, a coefficient, an x, and a y, and the exponent tells me how many I had altogether. Multiplying a monomial and a polynomial basically involves distributing the monomial through the polynomial, following the monomial by monomial steps. So just like we distributed an integer through parentheses, we can distribute a monomial through parentheses, and we just need to keep our exponent rules in mind. So here I have 2x to the third times x to the third. Well, that will be 2 times 1 is 2, x to the third times x to the third, plus 2 times 3 times x to the third times x squared. So I'm just writing out my numbers here to follow my monomial times monomial steps. Then I have 2x to the third times negative 2x, so that's times a negative 2, times x to the third times x, plus 2 times 5 times x to the third. And this does not have an x term on it, so I just have that coefficient here. Now I'll go back and simplify. X to the third times x to the third gives me x to the sixth. So I have 2x to the sixth. 2 times 3 is 6. X to the third times x to the second gives me x to the fifth because I add my exponents. Here I have 2 times a negative 2, which is a negative 4. X to the third times x, remember that's got an invisible coefficient of 1, so x to the third times x to the first gives me x to the fourth, plus 2 times 5 is 10x to the third. And that's my answer. I had a monomial times a 1, 2, 3, 4 term polynomial. We don't have a name for a polynomial that has more than 3 terms, so we just call it a 4 term or a 5 term or so on. So we have a 1 times a 4. 1 times 4 is 4, so I should get 4 terms here. And I do. I get 4 terms in my answer, and I am done. I can't combine any terms here because they all have different variable parts, so my work is done. When it comes to multiplying 2 binomials, we have several different methods that we can use. The first is the table method, and it's probably the most visual approach. In the table method, we will write subtraction as addition in each polynomial by flipping the signs. So the first thing you want to do is get all plus signs in the middle. So here I want plus a negative 4. And this one's already plus, so I'm good here. Now I'm going to make a 2 by 2 table, which I already have drawn out here. I'm going to line up the terms of one binomial across the top and the terms of one binomial along the left. So I'll take this x plus negative 4. I'll put my x here and my negative 4 here. Then I'll line up this one down the side, so 3x and 2. Now I'm going to fill in the table with the products of each set of terms using the monomial by monomial steps. So I'm going to multiply 3x times x, and that gives me 3x squared. Then I'll multiply 3x times negative 4. That gives me negative 12x. I'll multiply 2 times x, and that gives me 2x. And then 2 times negative 4 is negative 8. Now I'll write each of the 4 terms out in a sum. 3x squared plus negative 12x plus 2x plus negative 8. And then I'll combine my like terms and write my answer in the form of a polynomial. So I can't combine anything with my 3x squared, so that term stays the way it is. Negative 12 plus 2 is negative 10, so I'll say minus 10x, and at this point I'm fine to revert back to subtraction. And then I have plus a negative 8, which is just minus 8. So there's my answer. The table method allows us to line up our two binomials, create a chart here or a table, and then just add up all of our results and combine our like terms to simplify. The next thing we'll look at is the FOIL method of multiplying binomials. The FOIL method is a way of doing this algebraically, so we don't need to draw the table, we can just multiply the terms. And the way we do this is by multiplying first the first terms, then the outside terms, then the inside terms, and then the last terms. And we call it FOIL because we do first, outside, inside, last, or F-O-I-L, FOIL. So we're going to write each of the four products as a sum and then combine our like terms. So what we'll do is we'll take the first terms, so that's the first term here and that's the first term here, so we have 2x times 4x plus, then we have our outside terms, 2x plus 1, or 2x times a positive 1, so 2x times 1, plus our inside terms, 3 times 4x, plus our last terms, 3 times 1. So again, that's first, outside, inside, last. So each of these two terms is multiplied by each of these two terms. So we have 2 terms times 2 terms gives me 4 total. So 1, 2, 3, 4, and then I'll simplify and combine my like terms. 2 times 4 is 8. X times x is x squared. 2x times 1 is 2x. 3 times 4x is 12x. And 3 times 1 is 3. Now I'll combine my like terms here in the middle. These are both x terms, so they have the same variable parts. So then my answer becomes 8x squared plus 14x plus 3. And that's my solution. I can't combine any more terms because none of these have the same variable parts. So that's it. In our next video, we'll talk about multiplying polynomials, for example, multiplying trinomials and binomials with trinomials.